So welcome to the DEB Pre-Junior Cert Graphics exam in 2023. We're looking at question 4 here. The image on the right shows a driveway entrance. Right here. Shown below are an image of one of the entrance gates and an incomplete drawing of the gate. So we've got a gate there and an incomplete drawing of the gate. Complete the drawing of the gate by inserting 6 missing vertical rails which are equally spaced apart. Okay, show all constructions. So they're saying we need to show construction. We can't simply come along, measure this and say, right, divide it by 6, say, and mark it out. We need to actually show a construction. So the construction we're going to use is dividing a line into equal parts, and in this case 6 equal parts. So on this side I'm going to draw a line at any angle. Okay. And then I'm going to get my compass, set it to any distance, so any angle and any distance. I'm going to step out 6 times. 1, 2, 3, 4, 5, and 6. Okay, and always number these just to make sure we are going the correct amount of steps. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, now we're going to join that last point, point 6, back to the other end of the line. Okay, and that is the important line that we are looking for. Okay, we're going to go back then and use that angle. So this is why it's important. I'm going to do parallel lines to this on each one of these. Okay, so they are all equal distances now. Okay, and I need to show my vertical rails. So vertical rails we will draw vertically. Okay, so that is question 4A completed. Part B then. The image on the right shows one of the gate hangers used to hang the gate. Okay, so it's this bit that the gate will slot into and it will hold it in place against the pillars. The incomplete drawing of a similar gate hanger is shown below. Complete the drawing by constructing an axial symmetry on the line LL. So L1 is our axis of symmetry. So all of these points need to go through the axis of symmetry at 90 degrees, and it's going to be, so the distance to the center point there will be the same distance to the opposite side. It's a mirror image. So this is essentially the position of our line L1. So let's establish our points. We've got A, B, C, center point is D, E, F. Okay, so let's just double check our axis is a vertical line, so we need to go through at 90 degrees, so that's going to be a horizontal line. A projected through, B through, C, D, E, F. Okay, so they're all projected through at 90 degrees. Now the distance from L1 to A will be the same on the opposite side. Find me A1. So A, that distance, keeping my point on my axis, swing an arc, that finds me A1. Go to B, which happens to be the same distance, swing an arc, that finds me B1. Okay, so we're showing all the constructions here. We can't just draw a vertical line even though we know it's vertical there. I'm going to show exactly how I found it. So C, follow that line into my axis, right, get that distance on my compass, swing an arc, that's C1. D and D are actually going to be the same distances, but let's show how we got them. E, show how we got it. F, actually same distance again, but we'll show how we got it. So let's label all those: A1, B1, C1, D1, E1, and F1. Okay, and we'll follow it along. So A, 1 up then to B1, over from B to C. So we're getting this mirror image. Okay, F and E are going to join up. So we'll join F and E up, and F will join back to L. The last one then is D. It's going to be found over here, and it's going to be an identical radius, so same radius as on the opposite side. Okay, so that is part B completed. Then last part here, last part of question 4. The elevation and plan of a similar gate and pier or pillar are shown below. The gate opens about point O as shown by the broken line in plan. So our gate is in this position, okay, and it's been, you can see an edge of it, it's been rotated open to a new position, and we're going to have to find the elevation of the gate in the open position, so we'll project up and find it over here then. So let's get a compass. Okay, so we have the outside of the gate, and we have these to bring through. Okay, and this is a curve, these are straight lines, so they're going to stay at that same level. But all of these points, all of these vertical members have different heights that we're going to be projecting across. I'm going to give them names. So we'll go 1, 2, 3, 4, 5, 6, and 7. Okay, so let's project all of them down. So 1 is to 1, 2, 3, 4, 5, 6, and 7 is point O. Okay, so I should call that point O really. Okay, now we want to rotate all of those around. So point 1 has been rotated firmly, point 2. So that's the new position for point 2 when the gate has been opened. Point 3. To show that the rotation happening. Okay, don't just draw your line down here, I like to show it to the examiner that I have projected it correctly, or have rotated it correctly. And point 6. Okay, so just to make this easy again, so we got 1, 2, 3, 4, 5, 6. Okay. These are the new widths, and I'm going to project them vertically up. Okay, all projected up, and now their heights haven't changed. They've rotated, like I said, rotated about point O into its new position, but heights don't change. So let's go point 1. Here's 1 projected over. There. 2, 3, 4, 5, 6. There, and 7, or point O is rotating, it's staying in the same position. Okay, and the base we can project straight across. So here we have the rotated gate. Okay, 1, 2, 3, 4, 5, 6. We need to draw that freehand curve starting here So, okay, so that's the new position of our gate. So that's question 4 completed.